Please join me in welcoming some new and familiar faces to our stage. Our moderator, Alice from House of ZK, is joined by Vanishree of Firma, Dr. Young of Snarkify, Shiv of Risk0, and Anthony of Matter Labs.
Thank you so much, Ashley, for the introduction. Very excited to be hosting this panel on what makes for an optimal proving service. As ZK becomes more widely adopted, the need for proving services becomes greater and greater. And this panel will really try to dive in and explore all the components that makes for an optimal proving service, focusing on efficiency, focusing on security, on decentralization, while balancing cost effectiveness. And then we'll also try to explore some of the trade-offs that exist in considering all of these factors. So to start, I'd like for each of our panelists to give a brief introduction of themselves and also the projects that they're involved with. So let's start off with you, Shiv.
Yeah, so I'm Shiv. I'm the CIO at Risk0. I have product and engineering reporting up to me. Been here like a year. And Risk0 is, of course, the ZK VM that we build, and Boundless is the universal ZK protocol that we build on top of that, that brings ZKPs to every chain. Yeah.
Hi, everybody. My name is Vanishree. I'm founder of Firma. Firma is a universal proof market. And my background is in cryptography. Been in the space, been working on cryptography before crypto was a thing, and yeah, excited to be here. Thank you.
Hi, I'm Yang. I'm the co-founder and the CEO of Snarkify. We are building real-time proving for Ethereum. We are a GPU acceleration team, and over the past 2 years, we have won 6 Z prizes. I think we are the only team who have achieved this. Thanks.
Hey guys, I'm Anthony Rose, CTO at Matter Labs, which is the company behind the ZK Sync protocol. And ZK Sync is building what's called the Elastic Network, which is a horizontally scalable architecture for ZK-based chains.
Great. Yeah, we have a very exciting team of panelists here. But starting off very broadly, I'm wondering if we can speak about, discuss about some of the key characteristics that makes a well-designed proving service. And then also, if we could address some of the main bottlenecks or main kind of limitations in existing proving infrastructure.
Yeah, maybe for me, it's security, price, performance, DevX. Yeah, at 4. So I think you have to nail all 4. If you're talking about backgrounds, my background is in marketplaces. Excuse me, my throat's a little bit. I worked at Amazon, Lyft, Grab, exchanging real services or goods. And you need all 4 to actually make the marketplace work really well. You need to make sure the prices are as low as possible. People get what they want as quickly as possible. And it's easy for them to get. You have to focus on all these things. Otherwise, really, the market will suffer. And then you have to overcompensate, either through the cost of acquisition going through the roof or cost of maintenance going through the roof.
I think it's cost, time, and security, which are the 3 things that the end user cares about. It goes all the way down to the value chain. And how good the proving service is will have a say on these 3 things. So these 3 things are paramount metrics for a proof market to be successful, and also DevX. So these 3 things are ongoing metrics. DevX is typically the adoption metric. So all 4.
As a GPU acceleration team and the GPU-based proving service provider, our customers care mostly about cost, especially those ZK ROPs. If you ask what's their number 1 concern about ZK, it's cost. The secondary consideration is maybe latency. However, if you improve their settlement time from 1 hour to 10 minutes or to 1 minute, it may benefit from them. But that's a secondary consideration for now. But eventually, they will have some protocol level benefit from real-time proving, for example, enabling interop, etc.
Yeah, I would broadly agree. I think the summary of cost, price, latency, and DevX, unambiguously the key metrics. I think there's some second order ones, but they're sort of buried under them. So for example, ZK can be complex, but complexity affects things like maintainability, auditability, and it really comes down to security and performance. So yeah, I think the summary is.
Yeah, there's also another thing I just realized is marketplaces are generally at least 2-sided, if not more. There's also like, I think like when you just spoke, I suddenly realized, oh, I was just talking about like builders, but there's the other side as well. People actually like participating in the market from the other side, providing the proofs. We kind of forget about them because they're usually sophisticated actors at the very least, unless you're doing some kind of pool proving stuff. But even then, it's like you expect a certain level of engineering ability from them. But Amazon will say customer obsession is like, you know, how you operate. Like if you make it easier for them and make it so that they're also making money. Now, to be very specific in our industry, to make sure they can cover their OPEX properly, right? Like, because machines don't run on vibes, they run on electricity, and then the guy shows up with the bill. So like, how do you like capture that as well, which is a little bit more businessy answer, but like you got to do all of it in crypto.
Yeah, absolutely. And thank you so much for mentioning that. It's important to consider not just from those who are looking to outsource their proofs, but also those who are providing the proofs, those that are participating in these proving networks. And maybe if we have time, we can go into some of the specific incentive mechanisms that may be ideal for that kind of model. But so far, I'm hearing that the kind of key characteristics have to do with cost, have to do with latency and time, with DevX as well, and with security. But then I'm also wondering if decentralization is also a component in this as well. Do you believe that proving services should be decentralized, or is there still a need for or advantages with centralized high performance servers as well, provers as well? Are there any kinds of trade-offs between both the decentralized proving and the centralized proving approaches?
Yeah, at least from our perspective, there's definitely going to be space for both. And there's use cases that make much more sense in a decentralized fashion and much more sense in a centralized fashion. For us, we're building a toolkit for building ZK chains. So there's this framework called the ZK stack. And there are good reasons that you might want to run with centralized proving or decentralized proving. So for us, we're going to provide support for both. For example, with ZK, you can build, even if we just limit ourselves to blockchains, which of course for ZK, we don't need to, we can go beyond, and there's many other use cases outside of that. But for a private Validium, right? If you want to be able to run a chain that's interoperable with the rest of the ecosystem, that you can still prove to the outside world is correct, but you don't want to expose state, well, you're going to probably want to run centralized proving services, and there's like good reasons that financial institutes might do that. But also for teams that want to be, building open, sort of more traditional public blockchains, just decentralized ecosystems are kind of the thing that many of us are here to build. So for us, we think there's a marketplace for both. We think there's, with the ZK stack, we'll support both.
Yeah, for us, like in a lot of ways, like Boundless, for example, is going to be decentralized from day one. The reason for that is like the more conversations we have in the crypto world, people just don't want to introduce new trust assumptions, right? So Eigen's a classic example. They're down the street from us. They talked to us and they said like, yeah, we can't do centralized. Why? Because, well, look at our business model. We can't really use something that's centralized. It just completely tarnishes our image. So from that perspective, like if you are able to bring the trust assumptions of the chain into the decentralized network, which is how we're building Boundless out, we don't introduce any new points of failure. There's no multi-sig nonsense, right? So we want to like make sure we do that. But I do agree, there are always going to be customers who are going to say, we're not on chain. We just need something fast and like we want it off chain. And there's going to be these unique cases, like one part of building a marketplace is there is some kind of like on-chain negotiation on cost or something else that introduces a slight latency. It's going to be minimal, but like it's going to exist. Some people are just like, oh, I want it faster. So there's going to be like centralized proving for them as well. For consistent workloads where you want to like negotiate like some kind of like pre-negotiated price. Like we have a mechanism that we're imagining that is going to be very useful on Boundless. Even then, let's like control cost. But there are these odd customers who don't even care about cost. Right? There might be like, oh, we got bags of money. I don't know who these guys are. I'm trying to find them, but like, for them.
I think there are. So think about a customer. What do they initially care about? Cost and time. Then let's say they delegate proving to a proving service. Now, readily, what is the next thing that they'll say? Okay, I'm delegating it to you, but how can I trust that you are not going to censor something? Because now I'm not the one who is doing it. I trust myself. How do I trust you? So that is where this is a second order equally important reason. Decentralization is a second order, but equally important reason the moment you delegate proving. And of course, there are ideological reasons, and rightfully so. We should have some ideological reasons, and they help us stay on track when we can't reason about things. So it's good to stay ideological and still have decentralization as an ideological goal. And I do not buy the fact that centralization is the way you can achieve efficiency. You cannot, ZK has these peculiarities, and you can the moment you understand these peculiarities, what you cannot achieve by delegating proving to a centralized service, you can achieve by understanding those peculiarities, baking those peculiarities in the way you orchestrate your proving, and have better efficiency. Better efficiency meaning better cost, better proving time. So decentralization.
I'd like to share my take. So I like the ideologic angle. I'll give a very practical angle. Again, start from the customer's view. They care about cost right now, no matter what way, who we work with. So actually, we use decentralization as a cost solution. Why do I say that? Because we need to move off public cloud. Once you move off public cloud, you immediately get a 5x and 10 times cost reduction. So the next question is, once you move off the public cloud, who is the centralized entity? Does Snarkify want to buy all the GPUs and become the centralized entity like another AWS? No, we don't. We don't want to spend the capital on that. So we just rent and source GPUs from existing third-party providers to provide cheap GPU rentals from AI or from crypto mining. It's very easy to find them. Then immediately this becomes a decentralized proving service solution to solve the cost problem that our customers care about. So that's how we apply the decentralization principle here.
Yeah, I actually agree with that quite a bit but it's kind of like two interesting concepts like intertwined into one, which is like in our industry, decentralization means like a very specific thing in the blockchain world, and you have nodes and stuff. For us, because computing is a commodity, like literally it could be some old man running this in a basement in Russia. Doesn't really matter. The real key to decentralization here is to use commodity hardware, right? So this way, your ceiling is AWS, public clouds. It's like there's this argument that people make, which is like, what if someone comes in and they have some unique technology that makes proofs a lot cheaper when they take over the market? I'm like, yeah, okay, then what? It's like, oh, then they'll just start price gouging. They'll increase it up to what? AWS. They can't go further than AWS because you're using general purpose sort of like hardware. The second you go into like weird custom stuff, that's when like decentralization sort of gets affected. So for me, I actually like differentiate between decentralization and prover diversity. You do want lots of like, just for liveness, you want at least like 3, if not like 4 large people, then like get like individuals to pump in as well. But to be honest, at least in ZK proving, because it's going to be commoditized, you're going to see a lot of like bigger players who are very good at running data centers and can like bring costs down to the customer coming in.
Yeah, and it's really great that you make that differentiation between the prover diversity and with decentralization. And yeah, as you mentioned, Anthony, there may be some use cases where perhaps decentralized proving services may make more sense depending on the use case. And then also, but to your point, like Vanishree and Dr. Jianan, centralization isn't necessarily the key for efficiency. There are ways in which we can have decentralization, but then also have that efficiency component. So really liked all these perspectives here. Also very curious to hear about your thoughts on how important hardware acceleration, and maybe Dr. Jianan, you have some more insights on behalf of Snarkify, but how important hardware acceleration is for scaling these types of proving services. What kinds of maybe recent advancements have we seen that are making a big impact? Yeah, curious to hear your thoughts on this, Dr. Jianan, but then also from the rest of the panelists as well.
Sure. This actually, I have a long version of answer, but I'll try to make it short. So like most people will come to us asking, well, GPU or FPGA or ASIC. 2 years ago, when we were raising our seed round, we are betting on GPUs, but everyone else, those hardware acceleration companies for ZK, was betting on FPGAs and ASICs. There are some technical reasons behind it that why GPU will win. We know that, but some other people may not know it. But I think we make the right bet, and still we believe for the next 2 years or so, we are still on the right track using GPU to accelerate all the ZK accelerations. So FPGA is already out of the picture. Let's talk about the ASIC a little bit. I believe there are opportunities for ZK ASIC. However, it's very challenging for them to actually win the market. On one hand, the market size is very small. It's like even too small for GPU vendors, not even to mention an ASIC business who need like $10 million or $100 million to tape out the chip. And another question is, ASIC companies are not really competing with teams like us. They are more like competing with NVIDIA plus us. So we are making ZK very efficient on existing GPUs. NVIDIA is improving the GPU devices. The ZK ASIC vendor has really beat us both, like to achieve a 5 times cost reduction or efficiency improvement to win the market. I'm not saying it's impossible. I think eventually we could reach there. It's just very challenging to build a successful ZK business, ASIC business.
I think maybe also just to add something that I think complements this answer is the rate of change and the rate of progress in ZK. I think at least personally surprises me, even though we're like working and believe deeply in the field. Taking a step back and kind of thinking about the evolution of our proof system. We launched, ballpark 2 years ago with version 1 of the proof system. 1 year later, we're doing a major upgrade that is now on mainnet. This year, we're working on another major upgrade. And GPUs give you that optionality over the future. And we're expecting every couple of years to sort of the rate of change is there, and we should have that level of flexibility to keep evolving the proof systems. Like pre-committing to a hardware service today would bind you to something that's maybe irrelevant 18 months from now.
Yeah. Also, and it's a very interesting point to think about, which is like how much is cheap enough, right? Like, and we have like really large workloads sort of like running right now, and we can see like, oh, this is what it costs, and then you talk to the customer and go, what if it was like 1/5 of that? Is that good enough? And they go, yeah, that'd be perfect, right? So there is, if you think about like demand as like a pyramid, right at the tippy top was when like, it was custom circuits, and there's like 5 people who could write them, 3 people who could like audit them, and they all meet in a bar and then exchange cash. ZKVMs have done this one interesting thing, which is like widen the pyramid up. Teams like Snarkify, who have like quite a lot of expertise in GPU tuning, we do too, and like we're doing a really good job of like bringing the cost down. And there's like this weird slide I have somewhere where I can just track our progress. Every quarter we speed up by like 4x. It's the minimum. I mean, obviously there is a limit after which like you can't, but that's a great trajectory to be on. I think getting too hungry with like ASICs is difficult, but there's another quandary here as well. You can't just ship an ASIC in a quarter. So when is the right time to think about ASICs? When is the right time? And it's you want to be able to see that kind of demand first, and project it out, and hopefully your CFO signs off on like 150 mil. Mine won't right now. Maybe later.
I think I share the same opinion that we are not ready for ASICs. We are probably not ready for FPGAs, even given exactly like Anthony said, the pace of change in in the proving algorithms doesn't give you the stability that it'll make sense to invest and use FPGAs and ASICs. But I think what might be interesting, which I haven't come across personally, is identifying these modular, likely invariable parts, MSMs and FFTs of maybe let's consider elliptic curves, and let's say there are MSMs and FFTs on some popular fields and popular curves, right? So what if we see FPGAs or even maybe ASICs, I don't know, at least FPGA implementations of these things that get called that we can call to, but the teams that I've talked to, they are frustrated with the pace of change of ZK, and they say that we've put so much effort, and by the time it is seeing the day of light, there is a new thing, and we need to change it. So I wonder if there is room for a different direction and abstracting the invariable parts out and giving that as having API for other CPU parts to call it.
Yeah, I can comment on that. Just accelerating the invariant part won't work, because that will introduce a lot of data movement and communication between the CPU and the accelerator. That's something you want to avoid. The only way to make it work is actually to move all the compute as much as possible to the accelerator. That means once you build the invariant part, like FFT and entities, you also need to build all the elliptic curve operations, polynomial evaluation operations. Then ultimately, you end up with a programmable GPU without like tensor cores or like ray tracing graphic stuff. That's basically what Fabric is building. So that's what it end up with.
Yeah, I mean, like we actually have a partnership with Fabric, right? Like I was going to add that in as well, like which is one of the key responsibilities of building a marketplace is to navigate all of this, right? Like I'm sure Oyong is right. Like, but also it's incumbent upon market makers to try everything, to like go investigate in person. Fabric's a great partner. They want to go give it a shot. They want to like, build this, and I'm fairly confident they're going to build something awesome, irreducible with their binary fields. That's another crazy approach, right? Like you want to go for the 3-pointers as well. Like I said, it is a pyramid. If you widen the pyramid and keep lowering costs and like keep commoditizing it even more, you want to take all these shots to see what the limit is. So I think there's a theoretical argument, but you also want to like give it all a shot. Like ZK VMs was like one was more my CTO and my CEO getting drunk in a bar, really, like literally, and coming out with like an answer. Like we need to like keep pushing that as well. It's also the ethos of crypto is to like try new things, not wait for the demand, but create the demand. So all in, I'm saying like, I guess it's hard, but you got to do it anyway. And we are.
Absolutely. And I also wanted to go back to some of our previous points, like what you mentioned, Shiv, about the prover diversity, and just also looking at it from the perspective of those who are participating in the network and supplying these proofs. I wanted to dive into a little bit more about some of the maybe optimal incentive models that you all see in incentivizing the fair participation among all the participants in the network. Are there any kinds of frameworks or models that you see as ideal?
I can go. There are various ways of incentivizing. So like I was mentioning a little while ago, you need to have some sort of a guarantee from external people who are generating proofs, because you're not the one who is doing it, somebody else is doing it. So how can you trust that? How can you incentivize them to behave per their commitment? And there are at a high level, there are two ways. One is you have redundancy, have 10 people do it. You hope that one of them will generate a proof, and one is good in one proof. Anyone who generates a proof, as long as it verifies, is good enough. Now, this is an inefficient way. What's a more efficient way? You have these people stake, and you slash if they don't behave. And you have them stake the amount that is like, so you want to, so that is one. And I think there is another interesting point on how to split the proving in such a way that if somebody doesn't do the work, you know that they're not doing the work early enough that you're, let's say, for example, take A100, take a ZKVM or ZKVM proof, just one machine, just sequentially does all the inner circuits, takes about a day. You can't wait for a day and then they say, oh, I don't want to do it. You don't want that situation. You want the feedback of them doing early enough. You want to cut things. You want to do that. And this is why I like ZK Syncs. So we are yet to integrate Boojum 2.0, but what I like about Boojum is that there are so many internal steps. There are 5 levels, and each level has these circuit prover. It also has this, even within the circuit prover, there are these modular parts: witness vector generator, witness generator, witness vector generator, and circuit prover. We get feedback on them doing or not doing, so that if they don't do it, we can quickly give it to another party, slash them, take the extra money, and further incentivize the next person to really do it fast.
Yeah, maybe just to add on. So yeah, we thought obviously a lot about this, and at least for us, one of the things we care a lot about is going to be the latency of proving. right? We don't want action X to happen and then the proof is generated or available 6 hours later or 3 hours later. We want to, and the industry is trending towards near real-time proofs, right? Particularly for use cases like interop, if you want to be able to do a thing on chain A, react on chain B, but without new trust assumptions, you're going to want to have seen that proof being generated and being verified. So yeah, we've thought a lot about this. We thought a lot about slashing models being a good one. Also because there aren't really strong incentives to be malicious, right? You can't generate a fake proof if your system is kind of implemented well enough such that you can kind of push it into a malicious state. So really all you're able to do is sort of denial of service style attacks. So slashing is a good mechanism, at least for where we are today, which is obviously relatively new in the industry, to protect against that being a kind of very real threat. And reputation for provers will likely be something that a lot of us are spending time thinking about.
Yeah, same here. Like we actually have like a very unique solution for a lot of this called proof of verifiable work, which you actually introduced me. Then more technical details will come out when our marketing says so, I guess. But in a lot of ways, like the key thing to focus here is, in my opinion, three things. One is this mechanism has to be baked into the market and also a function of the tokenomics as well. We are, after all, you have to use tokenomics. Like there's no other way to like align incentives. There is no centralized party to like keep everyone in check. So how do you actually think about that? And also like how do you actually use the properties of ZK to drive some of these incentives as well? Like you're not selling, diapers, right? So there's something about how we sell compute as well, which I think can be added into the market to make sure incentives align. A very interesting thing also is like you want to keep the liveness of the market up. Like, oh, there's no job, so I'll just switch off and like vanish. How do you like make sure there is an incentive for like staying live? Like in Uber's world and Lyft's world, when I used to like run pricing teams, one of the weird things is driver incentives. So like, oh yeah, just even if you don't get a job, we'll pay you a little bit, stay on. Now, interesting thing is like what would happen with these kind of incentives is like it actually lowers the cost of proving. Incentives are actually applied in the bids. So if you're able to actually like harness that power properly, right? Like to take two examples, Bitcoin and Filecoin, it lowers the cost of like, running stuff by like 90% odd. Can we get to that? We think we can. Like the way Boundless is designed, we think we can get there and we want to get there. Yeah, like I said, like I feel like there's a slowly one of these like lasers coming on my head as I get closer and closer to revealing all the details. But like, yeah, stay tuned is all I can say for now.
Okay, let me add 3 points with my own experience. So first, on the pricing side, I think existing in production systems are based on fixed price points. So for example, our deal with one of our largest customers, Grow, and our deal with our GPU vendor suppliers is fixed price. It's working in production. There's no marketplace yet. But in the future, I would imagine some marketplace will dynamically determine the price point. But right now, it's fixed price. Second point is Anthony's real-time proving incentivization compared with like generator proving in 6 hours. Actually, we were integrating with ZK Sync's prover. Like by default, it could be generated in an hour for a batch proof. But like ZK Sync engineers would ask, what's the price point if you generate within 15 minutes, for example? So that would make the proof generation cost much higher. So that's a trade-off between latency and cost. And then it's up to the customer to decide what kind of cost and latency makes sense to them. The third point is about how do you incentivize GPU suppliers. So the GPU suppliers are basically crypto miners. They're quite straightforward. Imagine you own some GPUs, hundreds of GPUs at home, and what do you do? Right now, there is pretty much nothing for them to make profit from. So as long as you give them something to compute that can cover their electricity cost with some 10% profit margin, they will do it. So that's just how miners behave. So they are not hard to incentivize. Just give them something and give them some profit. They will do it.
Are you the guy with like 100 GPUs lying around the house?
No. We own some like Bitcoin mining machines.
Yeah, incentive alignment is always a big priority here, and it's great to hear some of the specific models like Vanishree and Anthony that you're mentioning, and also with thinking in the shoes of these miners, Dr. Jianan. And I also liked the point that you mentioned, Shiv, about also considering those liveness guarantees as well. That's a very big factor. I also wanted to dive into some of the trade-offs that may come in with outsourcing these proofs to proving services as opposed to say, local proof generation. Perhaps some users in certain use cases that are, for example, privacy related, they may prefer to have that local client-side proving. But maybe, Vanishree, especially since you're part of Firma that focuses on proving services specifically, maybe you can shed some insight on this, on some of the trade-offs that come with outsourcing proofs versus the local proof generation. But then also wanted to hear from, like, especially Shiv from your side with Risk Zero, and Anthony from ZK Sync. I know that you guys are especially focused on optimizing for that developer experience. Wondering how this ties into the DevX component as well.
I don't think there is a trade-off. I think there is only a benefit by delegating. I honestly, and that is true. Immaterial. That is true for projects at all stages. Imagine a project at an early stage. Should they be thinking about, I want to test what I'm building. I'm building this POC. I want to test it. Now, should I do this on GCP, or should I buy bare metal? I don't know how much to buy, and if I do it on GCP, it's going to be really, really costly. I'm seed funded. What do? Let me delegate. They know, they have been doing it. They have shown that they can work with established teams and guarantee good cost and time. Let me delegate. For that, for that stages, it makes sense. For stages of established teams, they have huge. The market can be thick there, and every ounce of efficiency you can derive from the efficiency of proving market has a huge effect because the volume is really, really high, and you can add significant value there. So all in all, I don't see. So the nice property of ZK is that is of verifiability, right? Of soundness. So as long as it verifies, you know that it's sound. This is not the case in image rendering. This is not the case in AI itself, but maybe with ZK-ML. But ZK has this property, and to your question, I don't think it's a trade-off at all. I think it should become. So we are integrating with ZK Sync, we are integrating with Scroll, we are integrating with other teams, and this initial integration with ZK Sync should set the right signal out to the public, that out to developers, that do not worry about proving. This is part we are here to help, to benchmark, to help you run testing, etc. So yeah, I think everybody should do it from day one.
There is a small trade-off though, right? Like, because like the inputs are public in a public market, so you do lose that privacy angle, which is what, like, where the conversation. So privacy is like this, like, you know, like big tag item which covers like 200 things, right? Like for specific customers, when they say privacy, what they mean is, oh, I don't want random people to know what my inputs are. Can I like pick and choose who my provers are? Something like that, right? So there are ways around it, but like pure privacy. And you mentioned client-side proving. I have an internal doc which I haven't published yet. I'm title in working, but I want to write at the top is it's a $1 trillion opportunity. It's beyond blockchain, to be honest. Like, it completely breaks the client-server model. Modern computer systems or like web services, the way it works is like you log in and there's like a bunch of stuff on the server side, and servers, the companies don't trust what you compute on the client side. If you can do client-side proving properly, you flip that narrative. It'll take me like a few hours to actually draw out what that would actually look like, but you would change your entire experience of how you enjoy the web with like unbelievable security. Like, you're talking like, oh, like, you know, you'd be doing well if you track that properly, in my opinion.
Maybe just a small comment on the developer experience. Like, one of the really nice things that I think we'll see, and we're starting to see already, is services that can do proving massively lower the barrier to entry for teams that want to start building in the space, right? So, you know, rewinding a couple of years, and many of us in the space were like building these ZK systems. Yeah, it was pretty tricky, right? It took quite a long time. Even when you've got a system to the point where it's functional end to end, you have to think about hardware utilization, right? How do you get to the point where you're using, you know, close to 100% of your GPU, right? There's a huge amount of work that goes into building things that are operating effectively, where we're now seeing the prices that we're seeing for, ZK in production. So when you've got services that have taken that specialist and deep, technical work for you, and you want to stand up a chain today, I mean, there are toolkits that let you deploy your execution environment. You can wire straight in and immediately be proving. So what might have taken a year or 2 years of really hard and really specialist work a couple of years ago is almost something you can do in like hours at this point. And the rate of change is still staggering. So for developers in particular, it's going to be a massively useful accelerant.
Yeah, 100%. Which is why I think it's important to not think of these things as just marketplaces, but like protocols that are like a stack where everything comes in, and like you offer like it should be modular, keyword, I guess, and so that like other people can build things on top. You must be opinionated in the beginning so RISC-0 builds the entire stack. We have our own ability to aggregate and do all these things and run provers and all of that as well. But if someone comes in and says like, oh, can I just take that piece and make it really, really good? Or can I take this GPU and like, I know I've won so many Z-Prize, I'm going to make it really, really good. Yeah, come in, do that, right? Like that's how, and what we want to do is make sure everyone profits from these efforts. That's why you need to focus on the protocol. Really good point about the abstraction as well, because from my perspective, my experience, personal experience is I paid my mortgage by basically taking gigantic Ruby on Rails services and breaking them into microservices. But Ruby on Rails was like a revolution for the web service industry, because you just like, oh, I just write a couple of handlers and just run it, middleware taken care of. Apparently it's secure, it uses MySQL, everybody knows how to run it. Just what is the Ruby on Rails moment for like ZK? These marketplaces will like try and advance that. Internally, we have a little project that we're like trying to work on as well. It's a little bit opinionated, but like we would really love to make it like the Ruby on Rails for like ZK and like work with partners, right? That's important as well. If you try to do it alone, if it's some weird opinionated stack stuck to like one ZK VM, one ZK thing, one, if it's all like that, like you get stagnant like this. I understand there's an opportunity to like maybe like tokenize and immediately make money and stuff. Yeah, that's like that means your business model is worth 1 ETH Denver. You won't be back in ETH Denver 2026.
I actually want to respond to what Shiv said about I know we are running out of time, but real quick, this is very important, I think. Trade-off when you delegate, when ZK part of zero knowledge proving is important. You can't delegate because you have the sensitive information. That's why people are going to client-side proving. But there is a big problem in client-side proving. Huge problem in client-side proving. Why? It doesn't scale. It doesn't scale with the increase in the size of computation. It doesn't scale with the decrease in the size of devices. The moment you figure out, okay, this is the proof system, and this is the computation, and this is the country in which you want to deploy. Again, your BD goes to another country, they have flip phones, what are you going to do? And you build the bigger, somebody builds an application on top of you which has bigger computation, what do you do? It just is an architecturally unscalable solution. I think this is why, again, not to front run our announcement, but we are actually working on a way to solve this through the architecture. I would love to debate this with Shiv one day.
Yeah, I mean, I know it says time's up, but I'm going to answer the answer. My answer was very specific to privacy. Like, I worked in compliance for like large amount of time at Coinbase. Don't recommend it. Sorry, Coinbase. It's hell on earth. But it's mostly about transferring PII, personally identifiable information. You don't want to give your SSN anywhere. It's not computationally intensive to just keep it on device. You want to keep some stuff on device. There is no world where client-side proving takes over all verifiable computation. That makes total sense to me. But there is a world where it replaces a bunch of these like key things, your touch points to the web, where like security and privacy becomes like very, very important. Keeping your own information on your own device is possibly the best thing you can do to like keep yourself safe. I think to a large extent, all of us are now numb to losing our PII. At this point, I feel like every major rogue nation has all my details. I might as well just put it on the blockchain and just download it directly. But you want to get to a spot where like, so identity and access management is a $1 trillion industry. That gets completely appended. I'm not saying we're going to replace all of them. They will adopt this. Like you can bake it into browsers, right? So just for privacy focus, definitely larger computation. Like you don't want to heat your iPhone.
Absolutely. And it's very interesting to see those kinds of, depending on the users, what their choices are, what they're trying to go for. Vanishree, you mentioned that client-side proving has those limitations within scaling, but then at the same time, Shiv, you mentioned that for those privacy-focused applications, it may be more appropriate. But overall, really appreciate all the insights offered by all of our panelists today. For proving services, it's not just simply deploying it. There's many factors that one needs to consider with latency, with cost, efficiency, general incentive alignment, liveness guarantees, all of the points that we discussed today. So really appreciate all the insights from all our panelists today. Thank you so much.
Thank you.
Thank you.
Thank you.
Host.